This is Mercury, the innermost planet closest to our Sun. Mercury's days are longer than its years, and it has an elliptical orbit from 47 million kilometers at its closest point to 70 million kilometers. Difficult to observe from Earth due to the Sun's light, Mercury is an enigma of the solar system's evolution.
Well, Mercury is really a weird planet. The normal terrestrial planets, all the rest, have a relation between how big they are and how dense they are. Mercury is not following that rule. It's much more dense than what you would expect for its size. That is not normal, so something went wrong in the formation of Mercury that we don't know.
Only 2 probes have been sent to investigate the planet, and only one has achieved orbit. Mercury is difficult to get to because of its orbital speed and the gravitational influence of the Sun.
Mercury, for us, is a planet of extremes. So you have temperature like 400, 450 degrees on the surface during the day, and imagine that's like being in a pizza oven on Earth. So it's really hot there, and temperatures at about minus 175 during the night.
Mercury orbits the Sun every 88 days in an atypical elliptical orbit. At its nearest approach to Earth, it is 77 million kilometers away. The first close-up imagery of Mercury came from the US probe Mariner 10 in 1974. With insufficient fuel to slow the craft, it was not possible to put the probe into orbit. Instead, it orbited the Sun, passing by Mercury 3 times. The flybys provided 2 interesting observations. Firstly, Mercury has a magnetic field similar to Earth, which is unusual due to the very slow spin of the planet. Secondly, the surface of the planet showed extensive cratering and very little volcanic or crustal movement, 2 contradictory observations of why the planet has such a magnetic field. The second and most recent probe is Messenger. Launched in 2004, it made several planetary flybys of Earth, Venus, and Mercury to slow down to the correct speeds. It took 6.5 years to reach Mercury and enter orbit in 2011.
Because of this short distance from our central star, the temperature of the planet is very, very high. And when you want to fly around Mercury with a satellite, you find yourself in a very special thermal situation where you get a lot of heat coming from the planet itself that behaves like a thermal mirror. And then from the side, you get the heat from the sun. So you have 2 heating sources which may destroy a normal spacecraft. Another NASA mission, Messenger, is getting operational in a very loose Mercury orbit because, as I said, the thermal situation is such that you better stay away from the planet.
Its primary mission was completed within a year, mapping the entire globe with about 100,000 images. With fuel in reserve, the mission life of the probe was extended. After 10 years, Messenger continued to send back information and observations. Magnetic field data, the magnetosphere, the effects of solar wind plasma, and studies of the atmosphere of Mercury. It is so low in density it is constantly blown off the planet as an exosphere, revealing the likes of sodium, calcium, and magnesium in a trailing tail away from the Sun. Spectrographic imaging of the surface material has thrown up more questions about the high metallic density of the planet. The observations do not fit the standing theories of the planet's evolution, which will have to be completely overhauled. One other interesting detail: at the north and south polar regions, MESSENGER has detected the presence of water ice in the permanently shadowed interiors of craters, just like on our Moon. In 2014, the probe was tasked to fly much closer to the surface, as close as 50 kilometers. There it imaged the surface at much greater resolution, hunting for more detailed signs of the planet's geological history. Left unaided, the probe continued to descend and ultimately impact on the surface. There was, however, sufficient fuel in reserve for 3 trajectory alterations to increase altitude and give the probe a short time extension to continue its work into 2015. A third mission to Mercury is underway by the European Space Agency and the Japanese agency JAXA. Bepi Colombo is named after the Italian mathematician Giuseppe Bepi Colombo, who first developed the gravity assist maneuver for NASA with the Mariner 10 probe. It consists of 2 orbiters, the ESA Mercury Planetary Orbiter and the Japanese Mercury Magnetospheric Orbiter.
What scientists want to do is try to understand the nature of the planet itself. What material is on the surface. We would like to measure temperatures. We would like to see the interaction with the solar wind. Then Mercury has a magnetic field, which is like Earth, a dynamo field. We would like to understand that.
The Japanese MMO will focus on the magnetic field environment around the planet, while the ESA probe will focus on the planetary surface. Like the previous 2 probes, Bepi Colombo will use Earth and Venus to slow the probe's speed down to drop closer to Mercury's orbit. This trajectory will take approximately 7 years to accomplish, with solar electric motors to maintain deceleration. Then a conventional rocket engine will be used for orbital insertion. The orbital life of the probes in the harsh environment is expected to last 1 to 2 years. The 2 craft carry a suite of the most advanced instruments, including a laser altimeter and magnetometer, infrared and ultraviolet spectrometers, imaging X-ray and high-resolution stereo cameras. Bepi Colombo is designed to answer specific questions about this planet. Why is the planet so dense? How did it form? Is the planet tectonically active? Why can no iron be identified on the surface? In the absence of any ionosphere, how does the magnetic field interact with the solar wind? How is the magnetic field generated?
We have a theory to understand how planetary systems form. Now, the theory was based on explaining the solar system, and it was fine, it worked. But now, when we have discovered new planets around other stars in the galaxy, the extrasolar planets, they don't fit at all. So something is wrong. And the special cases, those that are difficult to understand in the details, like Mercury, are very helpful.
By finding answers to some of these questions, Bepi Colombo will help us understand how the solar system was formed 4.5 billion years ago. It is the first and brightest star you see at night. our sister planet in some ways, our closest planetary neighbor in both distance and diameter. However, Venus is difficult to reach, and a very strange world when you get there.
In the early days of the solar system, Venus and Earth must have been very similar. But then something happened, and they took a different route in its evolution.
Venus is the only planet in the solar system that needs more time to rotate once around its own axis than it rotates around the Sun. There must have been a major disaster in the early history of the planet where it collided with a big other object. And this made it stop its rotation. The problem is that without the protection and without the rotation, the planet lost its water, and so it's completely dry. And this, in the end, led to a horrible greenhouse effect that caused the temperature to rise to the levels that we see
One of the main differences between Venus and the Earth is simply that Venus doesn't have a magnetic field. So the way it interacts with the star is completely different. If you want to understand how did Venus get that way, why does Venus not have any ocean, you need to understand the interaction between the star and the planet.